All right, so I'm going to go over the graphing logs worksheet here. So I'm going to do the first few by doing the inverse, and then we'll use the pattern, okay, after we do a couple with the inverse. So number one here, so I want to find the inverse here, so we know we're going to switch, okay, x and y. So we go x equals log base 2 of y minus 1 minus 2. Now we just have to solve for y, so we add 2 to both sides. X plus 2 equals log base 2 of y minus 1, and we rewrite it, okay, in exponential form. So it's 2 to the x plus 2 equals y minus 1. And then we add 1 to both sides, and we now have the inverse function, y equals 2 to the x plus 2 plus 1. Okay, so this is the inverse right here of the graph that we want to graph. So if I make a table of values for this, which we know how to do, then I could just flip it, and then I'll have my table of values for this one. All right, so remember this is growth. All right, so we're going to start with h, which is -2, and then we're going to do a couple problems, a couple numbers bigger than that. So -1, 0. Again, if you do anything bigger than that, it might be off the chart. This base is pretty small, so we could do another one if we want. If I plug in -2, right, that makes the exponent 0. 2 to the 0 is 1. 1 plus 1 is 2. Plug in -1, 2 to the first is 2. 2 plus 1 is 3. Plug in 0, now we get 2 squared, which is 4, plus 1 is 5. Plug in 1, you get 2 to the third, which is 8. 8 plus 1 is 9. Okay, so I know for this one, if I make a table of values for this problem now, I just take all my y's from this one, and they go on this side. So 2, 3, 5, 9. Then all my x's go on, become y's, -2, -1, 0, 1. Okay, we know that our vertical asymptote is 1, and our vertical asymptote is always x equals h. Okay, so that's our vertical asymptote. So, whoops, that wasn't very straight. Draw my dashed line at 1, and then plot those points. 2, -2, 3, -1, 5, 0, and then 9, 1's off, but it'd be right around there. And that is the graph of log base 2 of x minus 1 minus 2. And so my domain, right, is going to be all real numbers greater than the vertical asymptote, so 1 to infinity. And my range for all log functions will be all real numbers. All right. And if we're doing left end behavior, right end behavior, right, there is no left end behavior. So we would say, how is this graph behaving when x approaches the vertical asymptote? All right, and so that's not asked in here, but we talked about that in our class today. All right, so now number 2. Again, I'll do this one. Change colors here. I'll change all the colors. We'll do number 2 as well. Okay, so the same way, this is 1/3 here. Okay, so this 1/3, all right, means that it's going to be, the inverse is going to be a decay function. Okay, so now the graph is going to be kind of flipped there on when we look at it in the log function here. So it's going to affect, really just going to make our table kind of maybe out of order a little bit, but we'll see that. Okay, so let's flip this. X equals log base 1/3 of y plus 2 plus 5. We'll subtract 5. Get x minus 5 equals log base 1/3 of y plus 2. Rewrite it now in exponential form. So 1/3 raised to the x minus 5 power equals y plus 2. And so the inverse will be 1/3 raised to the x minus 5 power plus 2. Oh, sorry, it's a plus already, so we got to subtract 2 minus 2. Oops, if you could read the right handwriting. So this is my inverse function right here. Sorry for the sloppy handwriting. And then we got, so we're make our table values. This is decay function. So now when I put h, okay, if I put h in here, h is 5. I'm going to pick numbers smaller than 5. So if I plug in 5, obviously I get 0. 1/3 to the 0 is 1. 1 minus 2 is -1. Plug in 4, you get -1. So that flips it. 3 minus 2 is +1. Okay, plug in 3, you get -2, flips it, becomes 9. 9 minus 2 is 7. So my table values for the original problem, right? So kind of notice how I went smaller here. So that actually makes my flipping good because now my y's are in order from least to greatest. So -1, 1, 7, and now it's 5, 4, 3. Okay. My vertical asymptote is at -2. So I plot these points, -1, 5, 1, 4, and 7, 3. So that's my graph. My domain is going to be everything bigger than -2. So from -2 to infinity. And my range is all real numbers. All right. Oops. All right. So let's see if we can a little bit. Let me see the bottom of that page. Okay. Let's see if we can do number 4 using the other strategy. All right, which was picking the correct x's right away. All right, and so our h here is -6. All right, so if I draw my vertical asymptote at -6, all right, I know that the first x that I want to pick is going to be -5, one more than that. So technically, it's b to the 0, right, plus h. So 1 plus -6 is -5. All right, so if I plug in -5, all right, I get 1 in here. And then so log base anything of 1, okay, is 0. And then 0 minus 2 is -2. So what's the next x value I want to choose? The next x value I want to choose is 4 to the first, okay, plus h. Okay, so 4 plus -6 is -2. And why did I want to pick -2? Because if I plug in -2, -2 plus 6 is 4. Log base 4 of 4 is just 1. 1 minus 2 is -1. Okay, the next one I'm going to plug in, okay, be 4 squared, okay, which is 16, plus -6, which is 10. Plug in 10, I get log base 4 of 16, which is 2. 2 minus 2 is 0. So I'm already off the graph here. So let's just plot what we got. -5, -2, -2, -1. We know the x-intercept will be over here at 10. Okay, so we draw our graph. And it looks something like that. Domain, again, will be from -6 to infinity. All real numbers greater than -6, and our range is all real numbers. Okay, number 4, is a natural log. So that means the base is e. All right, so number e is approximately 2.7. Okay, so when we do our direct table, right, our x's are going to be written with base e, and then you'll use your calculator to approximate that value here. So we know our vertical asymptote is at +1. Okay, so if I plug in 2, right, 2 minus 1 is 1, so even base e, right, it's got to be 0. Okay, so 0 minus 3 is -3. All right. Now, again, the next one I'm going to plug in is e plus 1. The base raised to the first plus 1. Again, so you plug that in, right, and you're just left with e. Natural log of e is 1. 1 minus 3 is -2. Next one's going to be e squared plus 1. Okay, e squared plus 1 minus 1 is e squared. Natural log of e squared is 2. 2 minus 3 is -1. All right, so what is e plus 1? Okay, e plus 1, if I open up Desmos, type that in, right, it should be approximately 3.7. Get it open here. E, see, it's 2.718 plus 1, so 3.718. And then what's e squared plus 1? E squared is 7.3 plus 1, it's about 8.3. So when I come back to my graph here, this is going to be around 3.7, okay, and that one's going to be about 8.7 or 8.3. Okay, so we plot our points, 2, -3. All right, 3 point something, -2. And then 8 point something, -1. Right around there. And now we can sketch our graph. All right, so natural logs are not any more challenging to graph. It's just our base is e, okay, and so our x's will be these decimal values. All right, and so our domain again is just everything greater than 1, 1 to infinity, and our range is all real numbers. All right. Okay, so now continuing on here. So log base 2, all right, we'll just go directly to the table of values. All right, so again here, our vertical asymptote is -1. So I want to start my table of values at 1 bigger than that. So I'm going to start my table of values here at 0. If I plug in 0, right, you get 0 plus 1 is 1. 2 to the 0 power is 1. So 0 plus 1 is 1. Okay, and then we take the base. Okay, it's 2, raise it to the first power, 2. Okay, plus h. So 2 plus negative 1 is 1. So that's what I'm going to plug in. So I get 1 plus 1 is 2. Then I do 2 squared is 4. 4 minus 1 is 3. Plug that in. I get log base 2 of 4 is 2. 2 plus 1 is 3. This one I could do another one. 2 cubed is 8. 8 minus 1 is 7. Plug that in. I get 3 plus 1 is 4. So again, remember the y's are always just going to go up by a. And since a is 1, okay, so you plot these points, 0, 1, 1, 2, 3, 3, and 7, 4. And you have your graph. Domain is -1 to infinity. Range is negative infinity to infinity. Number 6, okay, so now our vertical asymptote is -2, which means our domain is going to be from -2 to infinity. And our range is always all real numbers. Okay, but our b is 1/2 here. So again, that means that it's decay. All right, so the graph is going to come down and make your logarithmic curve. But we got to make our table of values. So for when I'm going directly with the table of values now, okay, I'm still going to start 1 to the right. So I'm going to still start at -1. Okay, and so when I plug that in, I should still just get k. Okay, so 1/2 to the 0 power is 1. 0 plus 2 is 2. All right, now these y's are going to be going down now. All right, and when I plug in, I'm going to go 1/2 to the negative first, which gives me 2. Okay, 2 minus 2 is 0. All right, and that's going to go up by a, or down by a. Okay, so plug in 0, you get 1. Okay, 1/2 to the negative second. Okay, gives me 4. 4 minus 2 is 2. I plugged in 2, right? 2 plus 2 is 4, so that gives me -2 plus 2 is 0. All right, if I do it one more time, you get 8 minus 2 is 6. So I plug in 6, I get -3 plus 2 is -1. Plot these points here, -1, 2, 0, 1, 2, 0, and 6, -1. All right. Question 7. It's a natural log. So again, all right, my asymptote is 1. So my domain is 1 to infinity. And the range is all real numbers. My table of values, again, are going to have E in it. But we're still going to start one more than H. So again, H is 1. So we're going to start at 2. And whenever you plug that in, you always just get your K. All right. And then, so now the base is E. Okay. So it's E plus H. So E plus 1. So plug that in again. All right. That's just natural log of E is 1. 1 plus 3 is 4. Then I'm going to go E squared plus 1. Plug that in. Natural log of e squared is 2. 2 plus 3 is 5. All right, so if we plot these points here, 2, 3, remember e plus 1 is about 3.7, 3.74. And then e squared plus 1 was 8 point something. And so our graph will look something like this. All right, for 8 here, we're not going to fit much on the graph here for 8. All right, we're shifting it to the right 3 spots. So our vertical asymptote's at x equals 3, which means my domain is from 3 to infinity, all real numbers greater than 3. My range is still all real numbers, but we don't have much room on the graph here. So, but we'll go ahead and start at 4, and we'll get 4 when we plug that in. Okay, and then go 4 to the first plus 3, so that's 7. If I plug in 7, I get 5. Now I'm going to be off the graph on the next one here because 4 squared is 16. Okay, 16 plus 3 will be 19. So I'm way off the graph. All right, but we can plot these 2 points here, 4, 4 and 7, 5. And we should be able to draw our curve for the given coordinate plane that we were given here. All right, and there you go. And that should be just 2 more though. Let's erase all this, scroll down. Okay, question 9, log base 5 of x minus 1. So again, my vertical asymptote here will be positive 1. X equals 1. My domain is, whoops. My domain is 1 to infinity. 1 to infinity. And my range is all real numbers. And that's my range, that's my domain. Make my table of values. All right, so I'm going to start at 1 more than h. So I'm going to start at 2, and then that's going to give me my k. All right, then I take the base, all right, I raise it to the first, so 5 plus 1 is 6. I plug in 6, I get log base 5 of 5, which is 1. 1 plus 4 is 5. All right, now I'm going to be off, because my base is so big, I'm going to be off the table, but 5 squared is 25. 25 plus 1 is 26. And I plug that in, you get 6. All right, so I'm only going to be able to plot those two numbers there, 2, 4, and 6, 5. There you go. Now, number 10 here, my vertical asymptote is -3, which makes my domain all real numbers greater than 3, so -3 to infinity. And of course, my range is still all real numbers. Now, this has a very large base, right? We don't see it, but so with this, the common log, so that means the base is 10. So again, not much is going to fit on the graph here. We'll get 2 points in because at least it was shifted to the left 3 spots. So I'll be able to get a couple points to fit on the graph. So again, I'll start at -2, 1 more than h, right? And then it's always going to give me the k. Oops, I don't know why I wrote plus. Just 2 will work. Whoops. I don't know what that just happened there. I hit the wrong thing. Okay. And then 10 to the first is 10. 10 plus -3 is 7. So when I plug in 7, I'll get 3. And after that, it's 10 squared is 100, right? 100 minus 3 is 97. So clearly that is going to be off the graph. All right, so -2, 2, 7, 3. And that's all that's going to fit on the graph. And there you go. That's your worksheet for today. Okay. If you have any questions, please come to intervention.